Hi, I'm Stuart from the Norfolk Honey Company and welcome to another microscopy and beekeeping video. These videos are sponsored by Brunel Microscopes here in the UK, a fantastic company that produce a range of microscopes and microscope accessories. So if you're interested in getting yourself a microscope or you need some further accessories or consumables, then please do visit the Brunel Microscopes website. I'll put some links down in the description below so that you can link straight through to them. And today we're going to look at some measurements in microscopy. We've got a range of different items that we look at under the microscope, and sometimes, particularly with pollen, it's important to be able to distinguish how large the sample is so that we can narrow down the type of pollen that it is and eventually identify it. So we use a combination of instruments. One is called an eyepiece graticule and the other is called a stage micrometer. And we're going to take a look at those today, and we're going to see how we use them to measure any kind of sample that we have on our compound microscope. The microscope that we're using today is the high-powered or compound microscope, and it's produced by Brunel Microscopes and it's their model SP50. And what we're going to do is to take a look at a stage micrometer and also an eyepiece graticule, and I'm going to show you how you can calibrate the two so that you can take measurements from any sample that you have on your microscope. If this is your first time watching one of my videos, you're very welcome. Please do consider subscribing. We've got a lot of microscopy videos that you can take a look at, and also a fairly extensive back catalogue of other beekeeping videos that you might find interesting as well. So let's take a look at the eyepiece graticule and the stage micrometer. Okay, so what you can see here is the eyepiece graticule. It's a scale that goes from 1 to 10, and unfortunately, because of the angle of view with the 100mm lens, we can only see barely the number 1 across to number 6, but that's not a problem because we can take measurements from any part of the eyepiece graticule. It's just those individual markings that we need to be able to focus on. So the other thing that we can do is we can actually twist the eyepiece graticule around so that we can line it up with an object. So the object that we're looking at through the microscope doesn't have to be exactly square onto the scale. So what I'm doing here is just rotating the microscope eyepiece so that the graticule will swivel around. We'll take another look at this eyepiece graticule with a microscope slide in place, and then we'll be able to take some measurements. So let's now move on to the stage micrometer. Okay, so this is my stage micrometer. It's a microscope slide and it's got 3 scales on it, and we'll just move in closer and take a very close look at the scales that it has. So here's the close-up of the microscope slide, and you can see that we've got a scale that's 0.1 millimeters, 0.01 of a millimeter and 0.05 of a millimeter. So what I'll do today is concentrate on the 0.1 and the 0.01 scales because they're going to be the easiest for us to calibrate, and then we can start to take some measurements from some pollen slides. So let's pop this into the stage on the microscope and see if we can take a look through the eyepiece again. So here we have the eyepiece graticule, and the point at which we can see through the eyepiece because of the field of view is from numbers 1 to 6 on the eyepiece graticule. Now that doesn't actually measure anything. These are just units that have no significant measurement to them until we calibrate them, and we have to calibrate to each individual eyepiece on the microscope. So what we're going to do is calibrate the 400 times objective lens, because that's the one that we will tend to use when we're looking at grains of pollen and nosema. But if you are going to measure anything through any of the other objectives, then you would need to use the stage micrometer to calculate all of the measurements for each of the individual objectives. So because we're looking at very small objects, it's not possible to measure them with either centimetres or millimetres. We have to get down to a smaller unit, and the next smaller unit is called a micrometer, and there are 1000 micrometers or microns in 1 millimetre. And so the scale that we're using on the stage micrometer is a 0.01 millimetre scale. And so if you calculate that down, if 1 millimetre equals 1000 microns, then 0.1 millimetre will equal 100 microns, and 0.01 millimetres is 10 microns. So with that in mind, we can now pull the scale into the image and let's see how they match up. So here's the scale. Let's see if we can focus it in. Okay, so that's the scale that you can see moving in the background. The numbered scale is actually our eyepiece graticule, and what I'm going to do is to line up one of the longer black lines onto the number 1, and we'll just move it in very carefully. If we look at the scale, number 1 through to number 5 measures specifically onto 2 of the long lines. Each of the small lines is 0.01 of a millimetre, and we've already established that that is 10 microns. So we can measure and count from number 1 to number 5, and that will be 100 microns. Now the gap between those two major lines is 4 eyepiece graticule measurements. So 1, 2, 3, 4, 5 is 4 blocks. So if we divide 100 by 4, we end up with 25. So we know that each one of our eyepiece graticule measurements, when we're measuring at 400 times magnification, is equal to 25 microns. So now we can put a pollen slide under the microscope, use the eyepiece graticule and take a measurement from a pollen slide. So here we have a single grain of pollen, and you can see that as I move it along the scale, it fits quite nicely between the scale, the large markings, so between number 4 and number 5. And we know, having calibrated it to the 40 times objective lens, we know that the individual markings are 2.5 microns, and that therefore the gap between the large marks, which are times 10, gives us 25 microns. And if you check in any of the pollen identification books, you will see that oilseed rape has an average size of around 25 microns. So that confirms for us that this pollen grain is the correct size to be a oilseed rape grain of pollen. And that's a really useful tool to have when you're trying to identify different types of pollen grains. So there we are, we've been able to calibrate the eyepiece graticule, which is the scale that you can see, and that's enabled us to quite accurately measure a pollen grain, and that has given us another clue as to the type of pollen that it is. So that's it for today's video. I hope you find that useful. If, like me, you find maths a little bit daunting, then I hope that this has helped you a little bit in understanding how to take measurements through your microscope. If you haven't yet subscribed, please do subscribe. I'd love to have you along, and if you could give us a thumbs up, that would be great. Helps us with our rankings on YouTube. And we'll catch up next week with another video in the Microscopy from Beekeeping series. My final thanks to Brunel Microscopes for sponsoring this video, and I'll see you next week. Thanks for watching.